Welcome back. In this video we are going to deal with power triangle, three types of power and power factor. Okay. So first we will deal with power triangle. Okay. Now I am considering an RL series circuit. In the case of an RL series circuit, current is lagging voltage by an angle phi. Current is lagging voltage by an angle phi. Okay. Now that means the current I has two components, I cos phi and I sin phi. Okay. Now, so if you are multiplying each sides of the triangle by voltage, you will get VI cos phi, VI sin phi and VI. Okay. Now that means these three sides of the triangle gives three powers. Okay. These three powers are known as, first one, S. S is known as apparent power, P is known as active power, Q is known as reactive power. Okay. Now I sin phi is the vertical component of I cos phi is the horizontal component of I. Okay. Now here current is divided into two components, I cos phi and I sin phi. If you multiply currents by B, we will get the power triangle. This is the power triangle. In the second figure you will get the power triangle. Okay. This one is the power triangle. Okay. Now it is basically a right angled triangle. Okay. Now it gives a relation between P is active power, S is apparent power, Q is reactive power. Okay. Now first one, apparent power. The total power that appears to be transferred between the source and the load is known as apparent power. Or in other words, the power generated by the source is known as apparent power. Okay. That apparent power is given by S is equal to Vrms into Irms. Its unit is volt ampere. Okay. It is basically the power generated from the source. Okay. Now next one is active power or true power. The power which is actually consumed in the circuit is known as active power. That means the only power consuming element in an electric circuit is resistor. So the power consumed by the resistors is known as true power or active power. Okay. Active power is given by P is equal to VI cos phi. VI cos phi is the horizontal component of apparent power. So it is basically apparent power into cos phi. That is P is equal to S into cos phi. You can write it as P is equal to S into cos phi. Okay. Now the unit of active power or true power is watts. Then coming to reactive power, the component of the current in quadrature with the applied voltage is known as reactive or wattless component. Okay. That means the wattless component is I sin phi. The product of voltage and reactive component of current is known as reactive power. Okay. That is the vertical component of current is I sin phi. If you are multiplying voltage with I sin phi, you will get reactive power. Actually reactive power is the power which cannot be utilized. Okay. It is lying inside the circuit itself. Okay. That reactive power is given by Q is equal to VI sin phi. Okay. Its unit is volt ampere reactive. Okay. Unit of reactive power is volt ampere reactive. It is a horizontal component of it is a vertical component of apparent power. Or we can write Q is equal to S into sin phi, where S is the apparent power. Or we can write reactive power is equal to apparent power into sin phi. So basically reactive power is the vertical component of apparent power. Its unit is volt ampere reactive. Then coming to power factor. Okay. There are basically three ways of defining a power factor. First one, power factor is given by cos phi. It is cosine of the angle between voltage and current. That is, if you are drawing a voltage and current waveform, say this is voltage, so this is current I. Okay. This is the current I and this is voltage. Okay. So this is I am drawing an example of a RL series circuit. Here what happens? Current is lagging voltage by an angle phi. That is, if you are drawing the vector diagram, voltage is at 0 degree, current is lagging voltage by an angle phi. Current is lagging voltage by an angle phi. Whereas in the case of a RC series circuit, this is for RL. Whereas in the case of a RC series circuit, what happens is that you will get voltage. This is voltage, and current will be leading voltage by an angle phi. Current will be, this is current I. Current will be leading voltage by an angle phi. So here how you draw the phasor diagram? Voltage is taken as reference. Current is leading voltage by an angle phi. Okay. So what is basically power factor? Power factor is the cosine of angle between voltage and current. So here what is the angle between voltage and current? Angle between voltage and current is phi. Okay. So that is cos phi. Cos phi is cosine of the angle between voltage and current. Okay. That is about the first definition. Okay. Second definition is power factor. Power factor is given by resistance by impedance. Okay, it is basically taken from the impedance triangle. If you are considering the impedance triangle of a RL series circuit, for example, resistor is the vertical component, HL or inductive reactance is the vertical component, and here you will get what? Here you will get phi. Okay, here you will get phi. That is Z. Okay. So Z is, by using Pythagoras theorem, Z can be written as root of R square plus HL square. So what is cos phi? Cos phi is vertical component. Cos phi is adjacent by hypotenuse. What is adjacent? Adjacent is resistance. Hypotenuse is Z. In the case of a RC circuit, what do you get? This is resistance. This is HC. HC is exactly HC is, in the case of a RC series circuit, you will get what? Resistance is like this. HC is exactly point down. This is R. This is HC. And this is Z. Okay. The angle is phi. Okay. So in this case, what is this? What is cos phi? Cos phi is again adjacent by hypotenuse. That is R by Z. Okay. So power factor is also defined as resistance by impedance. That is taken from the impedance triangle. Third definition. Power factor is active power divided by apparent power. What is active power? Active power is VA cos phi, and apparent power is, active power is VA cos phi and apparent power is VA. So what will you get? VA cos phi divided by VA is cos phi. Okay. Now, in usual practice, we use word lagging or leading with numerical value of power to signify whether current lags or leads voltage. Now, here I will explain with the help of RL circuit and RC circuit. For example, in the case of a RL series circuit, voltage is this, current is lagging voltage by an angle phi. This is, I am taking it as voltage. This is current. Current is lagging, this is current I. Current is lagging voltage by an angle phi. Okay, or if you are drawing the phasor diagram, voltage is taken as reference, current is lagging voltage by an angle phi. That is, if current is lagging voltage by an angle phi, then power factor is lagging. Okay. Whereas, in the case of a RC series circuit or circuit having more capacity effect, voltage is starting at 0 degree. Current will be starting before 5 degree. This is voltage. This is current. Okay. So what happens is that here current is starting before 5 degree. Okay. Now if you are drawing the phasor diagram for RC series circuit, voltage is taken as reference. Current is leading voltage by an angle phi. Current is leading voltage by an angle phi. If this is the case, then power factor is leading. That is, if current is leading voltage, then power factor is leading. If current is lagging voltage, then power factor is lagging. If current is leading voltage, then power factor is leading. This is for lead. This is for lag. Okay. Hope you understood the concept of lagging and leading. Okay. Now, significance of power factor. The apparent power drawn by a circuit, that is S. S has two components. One is active power and reactive power. the active component should be as large as possible because it is for doing useful work. Okay, so the active power is a component of the apparent power which is performing useful work, or it is a component of apparent power which can be utilized. Okay, now if active power is basically active power is equal to apparent power into cos phi. Okay, if phi is equal to 0, what is the condition when phi is equal to 0? When phi is equal to 0, the circuit is purely resistive. If the circuit is purely resistive, then cos phi is equal to 1. Whereas if the circuit is purely inductive, phi is equal to 90 degree. That means angle between voltage and current is 90 degree. Then cos phi is 0. That means active power is 0. Again, if the circuit is purely capacitive, again phi is equal to 90 degree. There also power is equal to 0. Whereas if you are having RL series circuit, RC series circuit, or RLC circuit, what happens is that you will get some value for phi. That will be between 0 degree and 90 degree. Okay, so power factor is basically a measure of effectiveness of utilizing apparent power drawn by it. Okay, so what is active power? Active power is apparent power into cos phi. Apparent power is constant. Okay, how much power we are drawing from the generator, that is determined on the basis of power factor, or in one way you can say that power factor stands for the efficiency of the circuit. Okay, power factor stands for the efficiency. Okay, that is how much effective utilization you are doing with the apparent power is given by active power. Okay, now to summarize the RLC, and RLC circuit, the supply given is Vm sin omega t for R circuit, current is Im sin omega t, impedance is Z is equal to V by I. So impedance in complex form is given by R plus J0. So power is V into I. Okay, in the case of an inductive circuit, voltage is Vm sin omega t, current is Im sin omega t minus 90 degree, and impedance is V by I, that is equal to XL. XL is 2 pi FL, or omega into L. So impedance in complex form is given by 0 plus JXL, and power is 0. In the case of a pure capacitive circuit, voltage is Vm sin omega t, apply voltage is Vm sin omega t, current is Im sin omega t plus 90, impedance is Z is equal to Vi, that is X is equal to 1 by 2 pi Fc. Therefore what happens is that you will get a 90 degree lag in the case of an impedance triangle. So impedance is given by minus JSC. That is active. That means here phi is equal to 90 degree. If phi is equal to 90 degree, power consumed is 0. That is for a pure inductive circuit and pure capacitive circuit, power consumed is 0. Now coming to RL circuit and RC circuit. In the case of an RL circuit, supply voltage is Vm sin omega t. Current is lagging voltage by an angle phi. So it is Im sin omega t minus phi. Impedance is given by root of R square plus XL square. So you get R plus JXL, and power is VA cos phi. Which power? Active power. Okay. Now coming to RC series circuit, current is leading voltage by an angle phi. Impedance is given by Z is equal to root of R square plus HC square. In complex form, here it is lagging. So R minus JHC. So power is VI cos phi. Now in the case of RLC circuit, it can be current can be leading voltage or lagging voltage. So it is Im sin omega t plus or minus phi. So the impedance is given by root of R square plus HL minus HC whole square. So impedance in complex form is R plus or minus JHL. JH. If HL is greater than HC, then it is plus JH. If HL is less than HC, then it is minus JH. So the active power consumed is VI cos phi. So with that, I am concluding with the lectures on R, L, C, RL, RC and RLC series circuits. Thank you for watching.